Hi there, so you maybe have seen the last video I did about this scope. Now, some of you people have asked for a review, so let's do exactly that. And let's start with the inside. Take this apart with these two screws, these two, and the two in the top handle. Let me undo these and let's see what's what. Okay, so now the screws are undone. So let's pop it open. Let's just get to the elephant in the room, which is this here cap. They did a through-hole cap and put it onto two very tiny surface mount pads that are not even straight, and they just hot glued it down with some elastics. It's wack. It's really wacky. Also, they did glue on the heat sinks with elastics. Like, is elastics even thermally transmissive? Now, for this obviously, these cans where the analog magic is happening, obviously you want a noise to keep out. Surely these small solder joints will keep all the HF out, all the high frequencies will sure stay out. Nah, I don't think so. Like they did a good job with the guard trace, but why would you first of all solder it in place instead of using the high frequency fingering? And why would you solder it in place only in a spot? Like, this is wanky. Like, everything else with the construction of this thing, I mean, it's a bit cheap, yeah, but it's doing its job. But yeah, the elephant in the room is this here cap. What's that? 470 mic, yeah, okay. I don't think you get decent surface mount, but then again, like, why would you very definitely hand solder a through hole cap onto two far too close, far too small, not even straight angle surface mount pads? Like, why would you do that? Yeah, but apart from that, interior looks good. Okay, so it's back together. Now let's look at the specifications a bit more. It's allegedly a 120 max scope, and that wouldn't be bad if it was that, and if we were to find out. That's the probes that come with it, and you see that's 100 meg probe for 120 meg scope. So if the scope was shitty or not up to spec, you wouldn't even know because you're limited by the probes anyway. I don't have any probes that are any better. Like, even the good in quotes text probes are only 100 meg too, but therefore 100 meg scope, so that makes a bit more sense. Okay, so you may see a second scope over there, so that's because I'm comparing to another scope, which in this case is the Kiprim scope versus the Tektronix TDS1202, which I have at work. And well, first off, use screen is bigger on the Kiprim scope, which is good, but also it's about as bright, and that's on 0% backlight, whereas the Tektronix doesn't even have adjustable backlight. Right now it's quite dark in here and it's good to see, but let me tell you, the Tech scope is hard to read in anything that's any more bright than this. And the Kiprim scope, well, I can turn up the brightness quite significantly. Got it? Okay, so now that would be 100% backlight. Now let's compare that again. It's like, yeah, it's brighter, and I have used the Kiprim scope for work stuff in a far brighter environment than this, and it's infinitely better than the Tech scope, so take that. Okay, so now let's try and check if this gets anywhere near its rated spec, which is by feeding in a clock signal from my FPGA board, which happens to be only like 50 or 60 megahertz. It's the fastest clock I have around. And let's see if it gets anywhere near. And yes, I do measure it with the ground lead attached to there. Literally because the high frequency clips thingies you put onto your tip directly, I don't manage to get contact. And you see a waveform. That's at like 20 nanoseconds a diff, and I could go to measurement and measure that. The measurement is completely off. Let me zoom in a bit more. Okay, so I'm zoomed in just as much as I can, and nope, it's not getting any better. The 20 nanoseconds per diff, or now it's 5, equates to something roughly the megahertz it's supposed to be. Now let's try the same with the Tech scope. Okay, so here's the Tech scope, and again I'm using the same circuit and general setup to measure things. Well, that looks like a sine wave, and we're at 25 nanoseconds per diff, so the same I was before, and it looks sort of similar-ish. Okay, so now I have a waveform here, and I have this same waveform that I recorded before on the Kiprim scope and just zoom it out. I didn't connect it again. And you see a difference in the waveform. So certainly this Kiprim scope has a bit of a problem with the frequency, but then again it could be anything. Okay, so retrospect. Is this thing any good? I don't know. At least the 50 megahertz tested sort of passed in the way that I would expect it to. But is it any good? I don't know. Yes, sort of. Is it any better than a 15-year-old tech scope? It has only 2 channels, so let's take that. But apart from that, I mean, it's okay.